Hi there. In this video, we are going to talk about the basics of inequalities. We'll save the more advanced methods of solving inequalities, like we were solving equations in the last video, for the next video. Okay, so in this video, we are just going to focus on how to understand inequalities, and we'll also talk about how to plot inequalities on the number line. So there are 4 inequality symbols that we use in mathematics. The first one that we'll talk about here is the less than symbol. And so you might be arguing against a ticket to a police officer, and you might be arguing, no, ma'am, I was traveling less than 60 miles per hour, just as an example. Another inequality symbol that we have is greater than, and this is can be said greater than. Sometimes people say more than. So I might say, my weight is greater than Bob's weight, or I weigh more than Bob. Another inequality symbol that we use is less than or equal to. So this combines the less than sign with the equal sign. So what we're saying is that to be less than or equal to means you can be less than, but you could also be equal. That is permitted. So another way to say this is to say no more than. Or another way to say it is to say at most. So for instance, you have a permit that allows you to use tennis courts. You are permitted to use those courts for less than or equal to 1 hour. So you can use them for less than an hour, or exactly 1 hour, but that's the most you can use them for. That you may also say that they may also say you can use them for no more than an hour, or you can use these courts for at most 1 hour. All those mean the same thing. And finally, we have the inequality symbol greater than or equal to. This is also read no less than, and you may also hear it said as at least. In a particular course, the amount of time you are expected to study per week might be greater than or equal to 4 hours. So you could study for more than 4 hours or exactly 4 hours. Those are all permitted. Of course, another way to say this would be you are expected to study no less than 4 hours, or you are expected to study for at least 4 hours. So these are the 4 inequality symbols that we'll use. Now let's go down and talk about how to interpret them on the number line. In these problems, we are asked to deal with the following inequalities. And we are asked to sketch the solution set and express it as an interval. So to sketch the solution set, we have to think about what values x satisfy x is greater than 3. Well, you might say, well, okay, well, the numbers 4, 5, and 6 are greater than 3. And that is correct, but that wouldn't be a complete solution because there are numbers other than 4, 5, and 6. There's 4.5, there's 5.9, there's 3.14159, our favorite number, pi. There's lots of numbers in between the integers that are greater than 3. And so we have to sketch all of these. So we're going to start at 3, and we're going to include all those numbers that are greater than 3. So we're going to sketch that all the way to the right. Now I have to stop when I hit the limit of the graph, but we should understand that this extends all the way out forever. Now I drew a circle around 3, but I was careful not to fill that circle in because 3 is not greater than itself. So I do not fill this in. I leave it as an open circle. And that indicates that all the numbers to the right of 3 and up to, well, let's say down to 3, but not including 3, are in the solution set to this inequality. Now let's express this as an interval. Interval notation has us write a pair of values that indicate the lower and upper bounds of the set that we just drew. So this set starts at 3, so I'll write 3, and it goes up to, well, it doesn't have an upper limit. So if it doesn't have an upper limit, I write infinity. So I write 3 comma infinity. The comma is just to separate these. Now I need to specify this open circle here. Well, in interval notation, what I do is I use a round parentheses. That's the symbol we use when you don't get to that number. You just go down to that number, or up to that number if it was on the right. Now, infinity, you can never get to infinity, so you will never put anything but a round parentheses near infinity. So that is the interval notation for this set of values. Let's go to the next one. X is greater than or equal to 3. Well, we know x is greater than 3 is the solution set that we just drew. So it's all of these numbers from 3 on up to infinity. But x is also allowed to equal 3. It's greater than or equal to. So we fill this in because x is allowed to equal 3. And when we write this as an interval, I'm going to write from 3 to infinity. But this time, I want to indicate that I'm including 3. So instead of using a round parentheses, we use a square bracket. And that indicates that 3 is part of the solution. So note the difference. Now, infinity can never be part of an interval because it's not actually a number. So again, we have to use a round parentheses there. Okay, on this one it says x is less than 1. So we're looking at the numbers that are to the left of 1 on the number line. So 0, -1, -2, -3, etc. But also the numbers in between. So all the way up to 1, but to the left. So I've got to shade all of these. All of those values that I just shaded are in the solution to this. How do I write this as an interval? Well, I start at, well, it doesn't have a starting point. It goes all the way down to negative infinity. So I write negative infinity, use an open bracket, an open round parentheses, and I go up to 1, but I do not include 1 because it's less than 1. It's not allowed to equal 1, so I use a round parentheses there. What about this one, less than or equal to 2? Well, less than or equal to means it's to the left on the number line. So I go all the way up to 2, and I can equal 2. That's that or equal to part, so I fill this in. So I fill in all the values from 2 all the way to the left, and I keep going forever. If I go forever, that means I use the symbol negative infinity on the left, 2 on the right because I went up to 2, and because I include 2 as part of my solution, I use a square bracket. So keep that in mind. Square brackets indicate that the number is included. Round parentheses indicate that the number is not included. Next, we have what are called compound inequalities. These inequalities use more than one inequality symbol. So these are actually two statements in one. This statement is saying that -4 is less than x, and that means that -4 is to the left of x, and x is less than 2, so x is to the left of 2. So what that means is that the number x has to be between -4 and 2. So I go from -4 up to 2, and x is between those values. So I shade this set. And as an interval, well, we start at -4, so that's the number on the left, and I go up to 2. And because -4 is not included in the solution set, I use a round parentheses, and 2 is not included in the solution set, so I use round parentheses. And so this is how I would express that as an interval. Now, one very important thing to note is that the number on the left always has to be less than the number on the right. Otherwise, this doesn't make sense. Same thing in the interval notation. This number always has to be a less number than this one. If you don't have that satisfied, you've done something wrong. Okay, let's go to the next one. So let's read the first part. 0 is less than or equal to x. That means that 0 is to the left of x. So that means x is to the right of 0. So I'm going to plot x to the right of this point. Now x could equal 0. That's what that little line there means. It's less than, or 0 is less than or equal to x, and so I fill that in. And x has to be less than 5 if we read the right inequality. So less than 5 means it's to the left of 5. So I can go up to 5, but it's not or equal to, so I don't fill this in. So I shade up to, but do not include 5. So as an interval, I would write this from 0 to 5. I include 0, so I use a square bracket. And I do not include 5, so I use a round parentheses. And again, make sure that the number on the left is less than the number on the right. Otherwise, you've done something wrong. All right, let's look at this one. Negative 3 is less than or equal to x is less than or equal to 1. So let's look at this first inequality. Negative 3 is less than or equal to x. That means negative 3 is to the left of x on the number line. Or in other words, x is to the right of negative 3. So x is to the right of negative 3. So we're going to be shading in this direction. But it could also equal negative 3 because this is less than or equal to, so I fill this in. Now x is less than or equal to 1. So that means x is to the left of 1. So I'm going to go up to here. And it could equal 1. It's less than or equal to, so I fill this in. And x is between those, so I have to fill that in like this. And if I write this as an interval, I go from negative 3 to 1. And it can equal negative 3. I filled this in, so I use a square bracket. And it can equal 1. I filled that in, so I use a square bracket on the right. And again, note that this number has to be less than this number. Otherwise, we did something wrong. The order in which they appear in the interval should match the order in which they appear on the number line. Let's go to the next one. X is less than negative 2, or x is greater than or equal to 1. So either one of these needs to be satisfied. So what does it mean for x to be less than 2? Well, that means x is to the left of negative 2. So I'm going to shade to the left of negative 2. I do not include negative 2 because I don't have an or equal to. And then what does it mean for x to be greater than or equal to 1? Well, that means that x is to the right of negative 1, of positive 1, sorry. So I shade to the right. It could equal 1, so I fill that in. Now, how do I write this as intervals? Well, x is less than negative 2. Well, that's this interval over here. Well, it goes from negative infinity all the way up to negative 2. It cannot equal negative 2, so I use a round parentheses. Now, what about this one? Well, it goes from 1 to infinity. You can never equal infinity, so we use round parentheses here, but it can equal 1, so we use a square bracket here. Now, how do I join two intervals and say I want to consider both of them as part of the same set of solutions? We use a union symbol. So a symbol that looks like the letter U, and it means to union two things together, to unite them, to combine them into one set. Okay, let's look at these. X is less than or equal to 1. That means x is to the left of 1. X is greater than negative 4. Well, that means we're over here. Now look at what just happened. I shaded everything. To be less than or equal to 1 means we're over here. To greater than negative 4 means we're over here. But that covers the entire real number line. As an interval, we're going all the way from negative infinity all the way up to positive infinity. So that's how I write my answer. And I wouldn't actually plot these points. These are unnecessary. I shade over everything. The entire number line is shaded in. You don't actually need to draw an open circle or a closed circle anywhere. Just shade in everything. Finally, the last one. X is less than or equal to 1. and x is greater than 3. Well, if x is less than or equal to 1, that means that x is to the left of 1. So that means x is over here. And at the same time, x has to be greater than 3. So x has to be over here, and at the same time, it has to be over here. Well, that's not possible. You can't be in those two separate disjoint places at the same time. So this has no solution. So there's nothing to plot. And for the interval, I would write no solution. There is no interval that would describe this. There are no values x that satisfy this. Note the difference between or and. Or says you need to be here or there, and that's totally possible. We saw up here, you could be here or here. They can be disjoint. It's fine. But you can't have an and have two disjoint sets because x can't be over here and over here at the same time. And so make note of that distinction. Okay, so that was the basics of inequalities, understanding what the inequality symbols mean and how to sketch them as solution sets on the number line. So go practice, and I'll catch you in the next video.